Hello everybody and welcome back to this new video. Today we're going to be talking about the Toast Active Directory box from CyberSecLabs. Now this is a very difficult box and a very long box, so for that reason in this video I'm going to show the solution and I'm not going to go over the full enumeration and everything I enumerated because that would just take too long. But I will explain when that happens. So first of all, we'll always start with an nmap scan. In this case, it's an Active Directory box and there's no real surprises in the nmap scan. All of these ports are kind of what you would expect. So I'm not going to dig into that deeper. And the first thing I'm going to enumerate is SMB. And for SMB, when you enumerate, you can check default credentials, you can check an anonymous login, stuff like that. So let's use crackmapexec. For SMB, and we're going to try anonymous login, so I'm going to specify a username that doesn't exist with an empty password and see if we can get access to any shares. So I supply -shares so that if we have access, it will show us which shares we can read or write to, and then we supply the IP. And we see, okay, we have a valid login here, meaning we can log in with any username without a password. We can access a user share, and we can access this remote IPC share, which is default. Now, for the sake of this video, I'm going to skip over enumerating the user share because this one is empty. But that's something that you would do, obviously, if you're doing the box for the first time. But something we notice here is we have share names, such as Karen and Potato. Now, Karen is somebody's name, or could be somebody's name, so maybe these are shares of users on the box, and maybe we have just enumerated a couple of usernames. So let's say these are users, because that's something that you could validly guess, because in Active Directory, enumerating usernames could be very useful for doing various other attacks. So let's say, wait, we think these are usernames, you are quite positive of that, so let's echo these in a user file. So we're gonna also add a fake user to our user file. We'll then also add Karen, and we'll add Potato. And I always like to add a user that I know is not a user to a file, just because then when I do scans, it'll show, okay, this is not a user, and then when I get a different result for these, I know, okay, these are in fact users. So now we have ourselves a users file. Now what do we have with users? Well, if you go, for example, to Hacktricks and the Active Directory methodology, if you know one or several usernames, you could try doing an ASREProast, an ASREProast, for example, and that's gonna say if a user has this attribute that don't require pre-auth, then we can get the hash for that user, and from that hash that we could possibly crack that and get that user's password. Now, what does this mean? Well, this means that the user doesn't have to pre-authenticate with Kerberos in order to do stuff, and this is something that you wouldn't want to have any user. You wouldn't want this attribute set on any user because, well, we can get a hash for that user. So let's start doing that. To perform this ASREProast, if you want more information, you can go here and read all about it. But we can do that with impacket, and the script in impacket that we're going to use is called GetNPUsers.py. We'll then supply a users file, which is our users file, then an output file. We'll call that the hash, and then we say a DCIP, a domain controller IP, which will be our IP here. So we'll let that run. We have an issue here. We haven't supplied a target. So, and the target should obviously be what's it called? The domain name, obviously. So toast.csl. Let's see if that runs. Domain should be specified. Is it like this? No. Is it a different slash? Yes, I think it might be. Okay, so we have 3 results here. So first of all, we have a session error, client not found in the Kerberos database. So that's probably for our fake user. Then we have this user Potato doesn't have this set, so we can't get the hash for it. Notice that it skipped over user Karen, so that's maybe in our output file. And we have an output file, and yes, this contains a hash for Karen. And then this invalid principal syntax is because I have an extra new line here in the file. So okay, we have a hash now of Karen. Now what can we do? We can try to crack this hash. So let's use John with -- word list equals user share word lists rocku.txt and then our hash here. So we'll let that crack. See if it finishes quickly, and it does, and the password for Karen is manager. Now, well, now you have a user and a password. So you have some creds or a session, you could do more enumeration, stuff like that, and we will want to enumerate everything again from the start. So we could enumerate SMB, we could enumerate LDAP, just see if we can get a session, a WinRM session, RDP session, all that stuff. It's all stuff that you want to check. For the sake of this video, I'm not going to check all of that, and I'm just going to skip ahead to what the correct one is, and that's LDAP. So let's jump into LDAP here and enumerate it. Now, I've enumerated LDAP before in my roast video, but this time I'm going to do it more manually. So we're going to use Python for this. So let's hop in a Python 3 shell. And again, I'm not making any of this up. I don't know this by heart, but all of this can be found, for example, in our hack tricks, pen testing LDAP. We can see, well, we can do manual LDAP enumeration in Python by running all of these commands. And then we can get a naming context, and from that naming context, we can do searches in the domain and see if we can find any information, such as credentials in set for usernames in the description, stuff like that. So let's jump into it. We're going to import LDAP3. We're then going to say server equals LDAP3 dot server, then supply the IP address, get info is going to equal LDAP3.all. So that's our server. Then we're going to make a connection. It's going to be LDAP3.connection with our server. And here we're going to then supply our user, which is going to be Karen, and our password, which is going to be manager. Okay, so now that we have that connection, we can bind to it, which is going to actually make the connection. And if this returns true, then that was a success, and it was. And now we can do something like server.info, which is going to show us all the info in the server, and which is also going to show us the naming contexts. And we see domain controller toast, domain controller CSL. So we have the naming contexts now. So we know that when we do searches, we will use that as our search base. So let's actually do a basic search of the full LDAP. Yeah, let's use this one. Okay, and we'll change this to be the naming context that we found, so CSL, and then toast here. Okay, so that's true, and then we can get the entries by doing connection.entries. And that's quite a lot here, and we have a lot of information here. So let's see. So we have a poacher user. And what I'm looking here for users is a user that possibly has a description set, because it used to be common practice to put passwords for service accounts and stuff in the description of that account, because it shouldn't, well, LDAP shouldn't be accessible by others, so system admins would put it there for their ease. And that's something that often occurs in real life. So let's see if that occurs here. So we have service user, doesn't have a description set. We have hot potato, or that's a display name, but their actual name is potato. And they do have a password set here. They have a description set here stating new password and then supposedly the password for that user. So now, well, we have a new password for this user, so we can go all over again with our enumeration. We could again test RDP, WinRM, SMB, LDAP, see if there's any more new information. But again, for the sake of this video, I'm going to skip ahead and just say, well, we're going to check SMB. So crackmapexec, SMB for the user, potato, with the password, and then the password we had. Okay, the password, and then -- shares. If that's a success, I want to see what shares can this user access. And let's take a look at that. Okay, it's valid, so we have a login here on SMB as the user potato. And now it's going to show us what shares it can access, and it can access the potato share, and it can even write to that share. So that's interesting. So let's mount that share. I've already mounted it. If you want to know how to mount it, go to pinkdraconian.darkcode.com and search for mount, and I have a lot of videos where I already showcase that. So in our mount here, we can see we have this clearlogs.ps1 file here. Now, looking at that, we can see in that file we have clear logs every minute and then a command that clears logs every minute. Now, what is this file? Well, supposedly this is a script that's being ran every minute. And we can verify that. I'm not going to do that in the video because I would have to wait every minute, but I'm just going to explain how you can do it. So first of all, you would try to ping yourself and get a ping listener back. So to listen for pings, you could do run this command to listen for pings coming into your system, and then you could do a ping -n1 and then your IP address in the file. And well, you would see, okay, you're going to get stuff back. Now the CTF-exe that you see me using here, that's from my GitHub here, CTF bash tools, which has some useful tools that I like to use to remember commands and stuff like that. But okay, so this script will give us pings back. Great. So we have command execution, right? So then you would probably try to get a reverse shell, get a shell back to your machine. What I tried, for example, is this invoke PowerShell TCP one-liner from Nishang, and you will most likely notice that, hey, that doesn't work. I don't get a reverse shell. It doesn't work. And that's interesting because, well, your ping worked, so why wouldn't that work? Now, then you might come to the conclusion, well, there might be some antivirus, something running there that blocks it. Okay, so that's fine. Well, how do you get around that? Well, an antivirus mostly runs on disk, so maybe if you only put your code in memory, then that way it will get past it. And in PowerShell, we can do, for example, invoke expression, and then invoke web request, use basic parsing, and then your IP here, and then the file that you want to run. So for example, payload.ps1. You could try this, wait a minute, see if it works. And when you do this, you will notice that your server is going to get a request back for payload.ps1, but you're not going to get a shell back from that what the payload is executing, because the payload isn't executing. Now for this payload, again here I have the Nishang one-liner set up here, but this won't work again. But this line gets executed. However, in memory, something is blocking your payload from actually giving you a reverse shell. Now, what could that something be? Well, there is something called AMSI, which stands for Anti-Malware Scan Interface. And that is going to, in memory, search for strings in what's being executed and then block them if it deems them inappropriate. But luckily, we have a way to bypass AMSI, right? So this GitHub repository here is very good for telling us how to bypass it. So it explains a little bit about AMSI, and if you want more, you can definitely read his blog post about this and get more information. But it says, well, these are scripts that can help bypass AMSI, but the scripts themselves are also detected by AMSI, so we have to obfuscate them by using, for example, ISESteroids, which is what I'm going to be using. So let's pick one from here, and I'm going to use the Medgraber's reflection method. So you can copy this one, and this is going to disable AMSI in memory for a little bit, but these strings here, probably AMSI utils and some other strings in here, are already going to be blocked in memory, so we can't just put this in there. Luckily, we can obfuscate this with ISESteroids, for example, which is an extension for your PowerShell editor, so you can install it and then you can start it. So let's hop over there to my PowerShell editor here and put this in here. So let's put this here. Alright, so if you want to start it, you just type start-steroids, and then you can go up here to tools and then obfuscate code. If you press OK, you will see that this has now been obfuscated. And now we have this more obfuscated version of our bypass. So what can we do now? We can put that into a file, call it AMSI bypass, call it whatever, put that in there, and now we can use this bypass to execute our payload. Now, how are we going to do that? Well, first, what we want to do is we want to first invoke expression, get a web request going, do that use basic parsing again, from our web server, we are first going to grab that MC bypass and run that. So then MC is bypassed, so now anything we run behind here, we can just run in our free will. It doesn't matter because MC isn't there anymore. So now we can just, instead of grabbing MC bypass, execute our payload.ps1. So if we do this, that should hopefully work. Now all we need is a listener for our reverse shell. So I'm going to use netcat here and listen on port 444 because in my one-liner reverse shell here, I use that port. Now we'll have to wait a second here and hopefully it will work. I have my server up here, so we will be able to see when our requests come in and hopefully get a shell back. Okay, we see we've got our files have been taken from the web server and we now have a shell, which is great, right? So now we have a shell and we are the user potato. However, something sad about the shell is very, very unstable, so it will break soon. Now, so we want to get reinforce this shell or get a new one that is more persistent, that doesn't break all the time. How are we going to do this? Well, we can't just upload an exe like a Metasploit.exe or something like that to the box because, well, there is some kind of antivirus that's blocking that. However, we can use SMB and then use netcat on our SMB to run it. So what does that mean? Well, we can run files from an SMB share. We can run exes from an SMB share. So I have an SMB share set up. I can, for example, do this. Oh, well, it broke now. Then specify the share. I'll type it out here quickly so you can see. Specify the share, which is called pink in this case, and then netcat.exe. Now, this is going to run netcat from that share, so I don't need to upload it or anything like that. We can then specify cmd.exe and RIP so that we get a request back. So that we get another shell, right? So this is what we want to execute. Let me copy that and then get our listener back. But obviously you need to set up your SMB share here. Now you can use SMB server from Impacket, but in my case that didn't work, so I had to do it manually. And to do it manually, you'll want to modify etc samba and then smb.config. In this case, you specify your share. You can then have a comment, whatever, a path, and this is where your files will be, and then these other flags. And then you can do systemctl start SMB daemon. You can start the daemon, and once it's started up, well, your SMB share should be working. So okay, we already got a request back here, so let's test it out. So we'll do a rlrep netcat-lmvp 555 here. We'll run that. And also quickly to showcase, if I were to go to my share, so that's mount/pink, and I do an ls here, we see, okay, netcat is here. And in the meanwhile, we have gotten this netcat has connected to my port here, to port 555, and we have a shell down here that is stable. So that's great. So now we have a stable shell as the user potato. What's next? Well, we want to become a system admin, or we want to elevate privileges even further. So let's see if we can run WinPEAS and get more information that way about how to escalate. So we'll we have this this share where we can write here. So maybe if we can find the location on the box to where this writes, we have an easy way of uploading and downloading files. So let's just go to the home, and we see we have this directory shares here. So that is probably the directory we want. So if we go into that, we have another directory, potato. If we do dir here, we see, okay, well, this is the directory from here, so we can upload files really quickly to the box. So let's upload WinPEAS to the box. So we will copy WinPEAS from, and this is a terribly long name, so that's WinPEAS, then WinPEAS.exe, then again WinPEAS, then binaries, then x64, release, and then we finally have WinPEAS.exe. So I'll copy that over there. It'll take a second to copy because it has to copy over the network. But now if we do dir here, we have WinPEAS perfectly. So let's run WinPEAS.exe here and see what we can find. So, okay, we see it's part of the domain, so I guess that's the Active Directory domain. We have a lot of vulnerabilities because this box hasn't been patched in a while, and some of these might actually be vulnerable, but that's something that you can look into. I know for a fact that this one is vulnerable later, but yeah, that's something that you would have to look into, which we're not going to do right now, because there's an easier way, and that's why I always say, always read through your entire WinPEAS before starting to look into things and go too deeply in a rabbit hole, because sometimes there's a very easy path that you just might look over because you were too fast with those other things. Okay, so keep on scrolling. Don't find anything. Here we have some more users. We have administrator, Karen, poacher, and service user, which we had seen before. These are also users. All right, we'll keep going here. Processes, okay. These red ones are from me previously doing the box, so that's why I skip over them. But then here we have this service, hellescape, which it says no quotes and spaces detected. So we have an unquoted service path, and we have file permissions over this folder here. So how does this work, unquoted service path? Well, I've done this before, so I'm not going to go too deeply into it. But if you do like quote, you'll see, okay, in the deployable box, I did it, so you can watch that video for more information. But here, what will happen when this service, hellescape, is started, it will start looking for an exe. Now, in Windows, it's going to look in a very interesting way because of the spaces and the fact that there's no quotes. So what it's going to do, it's going to first look for program.exe. If that doesn't find it, it's going to look for program files purgatory up.exe, and then I guess up4.exe, and so on. And then eventually it'll find this one. But if we control this directory here, and we can make an exe called up.exe, and then start the service, well, then our exe is going to get run, and we can get code execution. So let's try that out. So first of all, we need to create an exe. Now normally I would use MS-Venom, but obviously we know there's some kind of antivirus, some kind of thing blocking stuff here, so that's not a good option. However, we have already bypassed that with our one-liner here, so maybe we can use that in a way. So maybe we can turn this PowerShell line into an exe, and that is actually possible. So if we go to on your Windows box and you download PS2.exe, which you can just download, this is a graphical user interface, and it's going to turn a PS1 file. In this case, this file just contains this one line, and you can turn it into an exe. So if you compile this, it's going to run and write an exe. That's it's going to execute these PowerShell lines. So now that we have that created, you can put it on your box, which I have already done. And now all we need to do is upload it onto the machine that we are hacking into. So let's copy it over. So let's copy it from here, documents. In my toast directory, we have up.exe, and let's copy it to there. Okay, perfect. So now we have it, and now I want to move it to that directory. So I want to move it from shares, potato, up.exe. And I want to move it to program files. I need to use the quotes here because of the space. Purgatory and to up.exe. So okay, now we've moved it to there. And now we are ready to try and start the service and see if we can get a callback. Now notice that we are using these same lines. So it's going to execute our payload, and our payload was set for port 444, so let's exit this and listen on that port. In the meanwhile, I'm also going to stop this script because it's still being executed every minute and it will interfere with me here, which I don't want. So okay, we have our listener going on. Let's start this service. So service start, and it was hell escape. Let's see if that works, and it does work, and we have a shell back. And if we say, who am I? Well, we are currently the service user. So that's perfect. However, this is again an unstable shell. Why? Well, the service is started and the process never really ends. It's kind of in an idle state right now because it gets stuck and eventually it will time out, which means it will break this connection. So we'll have to fix that in a way. Luckily, there's an easy way we can do that. It happened right here. You can see the service did not respond. So it'll break and it's not a good shell and it's not easy to work with. So let's see if we can get a better shell. Let's start this up again. Start the service again. How are we going to upgrade it? Well, we have this up.exe file that'll pretty much just give us a shell. So maybe we can just run it from here. So let's go to program files and then purgatory. And I forgot that. Is that going to mess me up? I believe it just messed me up. So okay, so let's quickly type it out below here so I can do it in a bit. Okay, broke. Let's get that connection again. Okay, now it's connected to this one, which is fine. So we can cd to there, and then we can run up.exe. We'll have to do /up.exe, and that will give us a connection here. And now whenever this breaks, this won't break anymore. So now here we have a nice shell as service user. Now as service user we can do more enumeration, see what we can do. And as we can see right here, the service broke here, or the timed out, and we still have our shell. So that's perfect. So let's move on to more enumeration. So as our service user, we want to do some more enumeration. We could run WinPEAS, we could run Bloodhound, we could do some manual enumeration by going, for example, to this Windows Local Privilege Escalation cheat sheet. And one of the things you will want to check is the PowerShell history. And we can see here it's in a directory here. So I've gone ahead and I went to that directory, and let's take a look at what we can find here. And we find two files. We have a host history and a server remote host history. Now, the reason there's two files is one of these files is for the local history, so a user that locally logged into the PC, whereas the other one is for the history of remote connections. Now we notice that these have a very small length, and this is only 6 bytes, so that's most likely nothing. But then this one has some bytes, so let's take a look at this file. So we can type that out, and we'll notice that this sets a password object with a plain text password. Now, what does this mean? This means that this user probably tried to log in on a different account with this password, so this might be the password of another user on this PC. So what we can do is we can spray this password, for example, for SMB. On our users file, I've added all the users that we found earlier with WinPEAS to this file, and this is very big. And we notice that none of them work for SMB. We could try WinRM. We could also try RDP. Well, WinRM doesn't work with the -- shares option, so we'll get rid of that. And that it doesn't seem to like that very much, does it now? Maybe we need to add a -I option? No. Let's see if I missed something here. That doesn't seem like I'm missing anything. Let's just add a different option here to see if that makes any difference. Okay, so for some reason it wasn't working without any options, but with a continue on success option it will work. And we will see, okay, we have a match for the user poacher. We can log in with WinRM. So now we can use evil-winrm, for example, to log in as this poacher user. So we're going to supply the IP address, then the user, which is going to be poacher, and -p with this password. Now we're establishing a connection, and now we have a connection, and now we can start all over again with our enumeration. So we could run WinPEAS again, we could do all of the things again, and you will come across who am I /all, and then will show you that you have debug privilege and impersonate privilege. Now, impersonate privilege is something we've seen multiple times on this channel already. We have impersonated in imposter with incognito, and we have used juicy potato in the potato box. However, neither of these two will work. For incognito, we cannot get a meterpreter session, or I wasn't able to get one, so that didn't work out. And juicy potato is patched on this machine, so that wouldn't work. However, we can do it in a different way. We can, for example, use mimikatz and then use token elevate. But the issue with that is it's hard to get mimikatz running on this box, since we have the AMSI that we need to bypass, and we also have some kind of antivirus that's blocking a lot of stuff. So how can we do that? Well, we could load SharpSploit on this box. SharpSploit is a very nice framework that you can, and then we can load the DLL that this generates, and from there we can run different things. Now, how can you load a DLL into your session here? Evil-winrm has a very nice thing for that. It has Dll-Loader, and that allows us to load SharpSploit, and then from SharpSploit we can do stuff like a SAM dump or all kinds of different stuff with mimikatz or different stuff. So first of all, we need a DLL from SharpSploit. Now how are we going to do that? We're going to clone this directory. Then you can open that in Visual Studio Code here. You can set it for release, build it, build your solution, build SharpSploit, and then you will get this binary folder with a release, and then in net35 you have your DLL that you can put on your box. So I've put that on my box here. You can see it right here, and I have this as my Python server that's still open on this, on the location where we have the DLL. So what can we do now? We can then load the DLL in here. So let's do that. We can do dll-loader-http and then -path, and then we can supply the path to our DLL. Enter my IP address, and then SharpSploit.dll. And it says that name is not recognized, and we can fix that by typing menu in evil-winrm and trying that again. Now it should work. Okay, it's reading the DLL by HTTP. If we take a look, yes, it did read this DLL, and now it's loading the DLL. So let's give that a second to load, and then we can use all of these nice functions. So let's take a look at what functions we have available, if there is a fast way to look at this. So there's a quick command reference. Let's see what this is all about. Okay, so here we have all the different kinds of commands we can run. Here we have something to do with tokens immediately, but I'm mostly interested in this SAM dump maybe, because it can show us passwords and hashes from SAM, and it uses privilege debug, and I think we saw earlier that we have the debug privilege. So that's something that is also interested in that we could do. So okay, now it's loaded the DLL. Now one last time we will type menu, and when we type menu this last time, it will enable us to have command completion. So let's check that out. So if I type, if I just press tab, it'll fix this for us. So now we have SharpSploit. Then we wanted to run credentials.mimikatz. So credentials.mimikatz. Let's see what options we have. So we wanted to try to do a SAM dump. So let's see if that works. So we're going to run that. We can see it does a lot. So first of all, it is going to elevate token. It's going to find a token as a system. Okay, it has impersonated successfully. Then it's going to try to dump the SAM. And as you can see, that works out just fine, and we get, for the user administrator, we get an NTLM hash. Now we could try to log in using that hash, so let's do just that. What we will do is, again, use evil-winrm. You could also try to crack the hash, but you can also just log in with the hash, which is way easier. So administrator, and then capital H with our hash, and now we get a session as the administrator. So that was this box. I thought it was a very, very good box, a very difficult box as well. I had a lot of fun learning a lot whilst doing this box and whilst recording this video. I hope you enjoyed it as well. I hope you learned something new. As always, if you have any questions, don't be afraid to leave them down below. I will answer as soon as I can. Hope you enjoyed this video, and I hope to see you back for another one. Take care.